हेलो स्टूडेंट, एक बार फिर से हम लोग ऑर्गेनिक केमिस्ट्री कॉन्सेप्ट क्लास में आप सभी का वेलकम। और अभी हम लोग वर्कआउट करेंगे SN1 एंड SN2 रिएक्शन। और उससे पहले समझेंगे न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन। ऐसा सब्स्टिट्यूशन रिएक्शन जो न्यूक्लियोफाइल्स के द्वारा हो उसे हम न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन कहते हैं। The substitution reactions which are carried out by the help of nucleophiles are said to be as nucleophilic substitution reaction. Haloalkanes have greater tendency to show the nucleophilic substitution reaction. So let's start with the topic nucleophilic substitution reaction. This is Rx, and Rx simply represent हैलोअल्केन। हमारे साथ साथ इसको लिखते जाएं और इसको ट्रीट करा रहे हैं न्यूक्लियोफाइल से। न्यूक्लियोफाइल्स आर द इलेक्ट्रॉन रिच स्पीसीज। ऑल इलेक्ट्रॉन रिच स्पीसीज आर द एग्जांपल्स ऑफ न्यूक्लियोफाइल। नाउ व्हाट हैपन, सी दिस halogen is more electronegative as compared to carbon. Therefore, causing polarity and makes the alkyl group electron deficient. Nucleophile interacts with the alkyl part and it forms substituted product, and halide ion is removing out. Stronger nucleophile displays the weaker nucleophile. Now, this nucleophilic substitution reaction can be explained by taking an example. CH3Br plus OH minus. OH minus is the nucleophile. Br become partial negative and carbon partial positive. Then nucleophile attack electron deficient carbon and it form methanol, and bromide ion is removed out. So it is an example of nucleophilic substitution reaction. Always remember that the substitution reactions which are carried out by the help of nucleophiles are said to be as nucleophilic substitution reaction. Now, the nucleophilic substitution reactions categorize into two parts. The first one is SN1 reaction. SN1 reaction simply means nucleophilic substitution reaction of first order, and the rate of such type of reaction depends only upon concentration of the reactant, and it is independent upon concentration of the reagent. And higher degree haloalkane have more tendency to show the SN1 reaction. Therefore, we are taking this particular example, tert-butyl bromide. It is 3-degree haloalkane. Now it reacts with KOH aqueous, and when heat is given, then the replacement reaction occurs and 3-degree haloalkane converted into 3-degree alcohol. 3-degree haloalkane converted into 3-degree alcohol. The name of this haloalkane is stirred butyl bromide. Stirred butyl bromide, and it is stirred butyl alcohol. Now see the mechanism of this reaction. Step 1. Step 1. Hydrolytic bond fusion of reactant molecule, that is stirred butyl bromide, is taken under consideration, and on heating it will produce 3-degree carbon and bromide ion. 3-degree carbon contains positive charge on it, so it is 3-degree carbocation. And you know very well that carbocation is a particular type of reaction intermediate. It is 3-degree carbocation, and it is said to be as reaction intermediate, and this state is slow state. And in slow state we can find out the rate of reaction. So rate equal to K, it depends only upon the concentration of the reactant, that is stirred butyl bromide, and one molecule is taken, so its coefficient raised into power, so it is first order reaction. It is first order reaction. And now the final step. In this step, the carbocation intermediate interacts with the nucleophile, that is OH minus, and this reaction occurs very readily, means very fast, and the product CH3 whole thrice C bond OH. This is the mechanism of SN1 reaction, and it is very important to note that sometimes it has been observed that lower degree carbocation formed, which can be converted into higher degree carbocation by the rearrangement process, that we will discuss in our upcoming classes. So this is the mechanism for SN1 reaction, which stands for nucleophilic substitution reaction. And the reactivity order of haloalkane towards SN1 reaction: 3-degree haloalkane greater than 2-degree, greater than 1-degree haloalkane. Higher the degree of haloalkane, more will be the tendency to show the SN1 reaction. And there are some more points that you must know about SN1 reaction. If the nature of the solvent is polar, then it favors SN1 reaction. It has been observed in most of the time that SN1 reaction preferred to occur in those solvents which are polar in nature or having high value of dipole moment. Now move on to the next part, that is SN2 reaction, and it stands for nucleophilic substitution reaction of second order. In this reaction, the rate of the reaction depends upon both the concentration of the reactant as well as the reagent, and this reaction occurs in single state through the formation of a transition state. So first of all, you just note it down this and we'll go for the SN2 reaction. Now move on to the next part of the today's class, and that is SN2 reaction. Take a simple example. CH3Br methyl bromide having no degree, KOH aqueous, and it will gives you CH3OH, that is methanol, and KBr. This is methyl bromide and this is methanol. Br replaced by OH. This is methyl bromide, and this is methyl alcohol or methanol. Now the mechanism of this reaction, HO minus, this is nucleophile, and we can write methyl bromide like this.